In preparation of doing a bunch of other stuff, I decided to do a quick check on my tailstock alignment, and as you can see, I'm a little bit low. So I guess this is where I delve into the fun of aligning a tailstock. Can't take it anymore. Where was I? Now before I do that though, I want to check exactly how I'm low. And not necessarily the amount, but what is making it low, if that makes sense. Let me bring you up a little bit. Okay, so here's my tailstock in all its nauseating glory. Now I need to know if my tailstock alignment is true with the table. So I could be low here because the whole tailstock is low, or I could be low because it's tilted, and that's something I don't see a lot of people check. So I'm going to throw an indicator on there real quick. There's crap in my way. Okay, I'm going to hold it forward. I'm going to pull forward because that's the static dovetail it gives on this side, just so I can keep some alignment but not be tight. I'm going to slide it around, and I can see that it's rising as I push forward, and that verifies. I just tap on the dial because I always get confused which way it wants to go. It's one of those bi-directional jobbies. Pain in the ass if you ask me. But anyway, tapping down on it, I know that it's rising up and the needle is moving up. So before I can really take care of the nose-to-nose alignment, I need to get alignment with the bed, because correcting this one is either going to throw it out or it might bring it all back in. So I know I have to shim the front end of this and try to get that parallel, and then I'll take another measurement at the nose, and then if that works out, then I can check my side to side. But this one is what I need to address first. And that's going to suck because I think I caused it. In my misguided attempt, when I was working with something that was off center and I didn't know it, I had gunk in here or a bad thing. Let me pull you back a little bit more. Now this is a factory dead center. I think I bought it when I first bought the machine. I went to Smithy and grabbed a bunch of little affordable things. But along the lines, I did make a dead center, you know, throw it in the chuck, one of those quick and dirty ones when you just need something that's true to the part at the moment. And I believe I grabbed that one by mistake, and I used that to work on the tailstock, and I wound up scraping the area that I have to build up now, because I did not check it for trueness before I put it in to the tailstock. So something you might want to do if you have a bunch of those, or even some store-bought overseas import centers, is just double check them. I mean, a lot of people don't think about that. I'm saying a lot because I know I didn't, and hopefully there's a lot of people like me, but you know, it doesn't hurt. This is a MT4 taper on my spindle, and I have an adapter, and these are 3 Morse tapers on my tailstock. But wouldn't hurt, just throw it in there, hit the motor, and make sure that your centers are actually trued up. The center I used, stupidly, checking my tailstock, was not. So I thought, as long as I'm going to check that one, I'm going to check them all. So I know this one's cool. Set that aside. This is another one I ordered off eBay, and I kind of like it because it has the interchangeable noses. If I have the tool handy, you can pull this out and put an assortment in there. I can't remember if I did a review on that or not. If not, I'll have to dig up the footage and put it up there. But I can put wider noses in there, or you know, inverted cones for whatever. But I just thought it was neat because if there's anything I need to make a special for, I could mill it, or I can turn whatever type of nose I want, because it comes separate than the live bearing. But as I've seen with a lot of import stuff, is they're pretty much made by vandals. So this may be running nice and true and steady, but it might be off or not concentric with the taper itself. So a lot of words to say it might be boogered. So let's check that one. Okay, I'll count that one as good. I'm getting no deflection up here at the point. And I'm pretty far out here, so if there was any kind of a slop in there, it definitely showed up, 4 inches from the headstock. And my other one, that also looks good. Check my bearing. It's got a little grab to it. I should probably get in there and clean that out. It doesn't feel gunky, so I'm assuming it's the oil seal. The little rubber shield in the front that keeps the gunkies out is probably dragging on the outside there. But otherwise, that looks true to me. I'm giving you the bird's eye view since you're out of my way that way. Okay, so that means taking this apart, I'm going to have to shim this, which I'm really not all that happy about since I don't have squat for shim material. Maybe someday I'll block this up on the table and face it off, but for now, let's take it apart and see what's going on in there. Since I got to dial it all in anyway, I'm not worried about losing my side to side. Of course, your adjustment may be different, but I trust you guys can adapt and overcome. Okay. I had scraped this down because I was only getting like a hair contact up front and a little bit in back. So it seemed that I thought this was the the major true surface or the register. So I took this down to match that, and it turned out that's not the case. I do need something up here. Now I think about how to bring that up. I guess now if I scrape this down, now I have to raise the whole thing up. So I'm still looking at shim, shim, shim. And I guess I really shouldn't worry about it. Small contact, not a big deal here because it's not a sliding, moving part, So I'll just have to get that out of my thinking that I wanted a nice flat surface here and get something up on this nose to raise up the front of the tailstock and get me a nice linear motion across the top of the bar, and hopefully that'll bring it in the back alignment with the front. Now, why is this important? Well, if you don't already know, if you're turning between centers and you're cocked one way or another, that's going to give you a tapered finish, because if you're above or below center height on your cutter, you're going to cut less amount of material. So if it's off either way, up or down, side to side, well, side to side in 3 directions, we'll say. If you're farther away, too high, too low, you're going to get a fatter end on this side because you're not going to cut as much material. If you are too far this way, you're going to have a smaller taper on this end because your material is going into the tool more. If you have the problem I have now, where my rod, my tailstock is dipping from front to back, or back to front, whichever the case may be, it's going to be unpredictable, because if my shaft or my tailstock, the heck's stopping it? Oh. Okay. So if this is dipping in the front, and it'll get higher as I retract it, so I may be fine back here, but when I extend it out, it's going to lower, and it's going to throw everything off. So it'll be too variable, and you can't get any consistency out of that. So it's going to be important to get that aligned parallel with your table. And that's what I'm trying to do now. So, yeah, I'm setting it on the bed. Don't scream. Okay, I'll take it off. Okay, quick and dirty might be something like paper. Matter of fact, it's probably going to be the easiest thing I've got to play with. It's not going to swell up against it, you know, it'll mush down after time, but it'll give me some time to order some shim stock or something like that. Not to mention, if you use flood coolant and you have cast iron stuff here, you really got to take this stuff apart every now and then anyway, because it builds up some stinky gunk. If you've ever taken apart old plumbing, old cast iron pipes in the house for the drains and such, and all that stink, it's not the food and it's not the poo, it's the deterioration of the cast. Maybe it is bacteria, I don't know, but it stinks like heck. You know, you got those certain smells that you just immediately identify, like burning insulation on wire. You can smell electrical fires from the varnish and insulation being cooked off. You can smell a burnt motor. You can tell a skunk when it goes by. Well, when you've got corroding cast iron, that's pretty distinct. And that's what I get running flood coolant. And I'm trying to find something that I can put on here that'll protect it, but it still seems to get in there. Tried my Aerocroil, that doesn't seem to work. I don't want to paint it because paint is well, that's a variable finish. It's not going to be smooth, and it will compress, and it tends to gum things up when you have to adjust it, so that's out. I was thinking of linseed oil because that is actually a protectant, and it hardens up like a paint, and I may try something like that, but it does turn hard and gummy, and it may give you the same problem as paint. So I guess the only thing you can really do is take this apart and clean it. Maybe put a bead of, you know, take your finger and swipe some sealant around the edges here to keep the gunk out. But you've got the, you know, the top holes where you bolt down the tailstock. It can seep into there. I mean, just water finds a way. That's just all there is to it. So if you're running flood coolant, just, you know, prepared to have to deal with that, which is probably why the misters and such are probably more predominant, it seems now. And the old timers just dab on some oil. You don't have the problem with cutting oil, but you just have to, you know, you have to sit there and babysit it, and you know, that's what you do. I guess that's the price you pay for shortcuts. You save time in your machining using flood, but you lose all that time taking a machine apart and getting rid of all the gunk. So anyway, I'm rambling again, I'm sorry. So for the quick and dirty method of verifying everything, I'm going to take some scissors and chop up some notebook paper and see what it does. I guess for giggles I can probably measure one and see what it's going to give me. Not that I have a clue of how much I really need to go up, because this is just fit and fab as you go along. Oh, these things are fantastic. This is I don't know where I got this. I don't know if I bought that in Dayton some 20 years ago or what, but it's a ball mount vise. Clamps onto a tabletop or what have you, and it's got the swivel ball. It's kind of neat. But it's always good to have a third hand, or 4 or 5 of them. Can't have too many hands. Okay, that looks like 0 to me. Doesn't look like to you, but like Stan says, you're just gonna have to trust me. Now his note paper was what, 2.8 to 3? This is probably cheapy import paper, and it's probably gonna be thinner. I should probably set that to inch, since whoever watches my channel probably plays in inches. What do you know? 3/1000. You know, it's really hard to imagine something that thin really having any kind of width to it, you know? I guess I'm just not a machinist yet. I'm still a tinkerer, and so a 3/1000th error is that much. Yeah, really think about that. Alrighty then, so looks like that'll work. So let's try 3 layers and see what that does for me. Better give this side a wipe. Look at that. That's where it starts smelling. When you see that dark snot there, give that a sniff. That smells like a sewer right there. Not to mention, if you got porous castings like this, and that gunk gets in there, it'll start eating it like rust, which I guess it basically is. And this is my centering pin. Which is a real pain in the ass to get lined up. Now, I can almost bet that's not going to be enough. And just like anything, you want to crank it down to your normal torque while you're checking, because you do have a compressible media here. And it may drop over time, of course. Well, have to take another strip and slide it in there. Alright, let's see what we wound up with now, just out of curiosity. Okay, knock that down. Still loose. Not loose enough. Okay. See, now that I tap on it, the reading changes, so I think I'm too far. Yeah, I think I'm pointing up now. And that's only 9 thousandths. That doesn't seem right though. Okay, you guys, the quicker guys have probably already caught on, but you can't yell at me through the screen, so I'm just going to have to fuzz this out for myself because I get easily confused. So, needle going up, numbers going up. Okay, that's good enough. Yeah. See that? Now I'm kicked too far up. Go figure. And that was just with 9 thousandths. And remember, we're talking about, you know, yeah, it's 9 thousandths here, but you've got, you know, pivot points and angles and stuff, so it all comes into play there. So apparently it did not take much, did it? Yep, I'm pointed up. So, take a piece out. No movement. Oh. Alright. I gotta go change my underwear because I'm really excited. But that's so much more parallel than it was. And you couldn't see it because of the glare of the light. Yep. That old glare phenomena. But here you go. I'll find you a better angle. I'm not breaking out no polarized film. Just gonna dial you in where you can see. Okay, hopefully that gives you something. That is so much better than it was, and that's only 6 thousandths of paper. I'm gonna call that easy. Now, put a center back in the nose, and let's see how it translates out at a 4.5 inch distance. And I'll use this one since the adapter is stuck on there. Double check it. Okay. Take my dead. Yep. That is so much better. Okay. And the other thing I forgot to mention, you know, as a part when you're turning between centers and getting a taper because your alignment's off. Also, when your drilling's going to be off because you're going to have wider holes, especially if as you're advancing, you know, if you're off here and you're advancing the tailstock spindle forward, you're diving into the part and you're going to start wallowing out the holes, so that's going to throw it off. Your center drilling is going to be off. That's, you know, typically why people keep their tailstock loose with a little bit of play in there, you know, because it'll sort of find center. But when you're snug down, you're gonna have issues. And if you've got a drill bit that the flutes aren't, you know, 100% symmetrical, one's got to cut a little bit deeper. It's either going to push or grab. And well, these are things you already know. But in case you don't, you know, make sure your tools are straight. And that's what prompted this whole little video to begin with. I have a tilt vise that I need to true up, and you know, you can't do that if the tools you're truing things up with are borked. So anyway, I'm so much happier with that, and the point is so small I have to get out my Tom Lipton goggles. Isn't it neat how we all got these how the guys got their stuff? We got the double boost lights, we got the Tom Lipton goggles. Guess we'll have to find out what everybody else has got. Oh yeah, I am so happy with that. Alright, let's see how we are side to side. Roll you over here, point you down. And plus, since you're looking at it, I can use the big screen TV to do my dialing in. Focus! Yep, just a little bit off. V-fix. We have the technology. We have the screws. See, this isn't a solid shaft through here. This was a modification I first did when I got the unit. And you can tell because this piece here is aluminum and that was just bolted onto the back. I used the original shaft and brazed and you know, pocketed, joined it, and brazed the shaft going all the way back. But there's a slight difference in the circumference or the diameter of the rear half. And when it reaches up here to the cam lock, or what was it? All right, Chuck, what did you call those things again? A split cotter, which I'm pretty sure it's what it is. At least that's what he called it. That it'll throw off my alignment. So I want to make sure I'm on the virgin shaft for this test. Actually, it got better. Maybe not. Okay, 1.5 thousandths in the amount of travel I can check. So that's something I'm going to have to take into consideration or find a way to correct. Since I don't have an easy way of changing that long alignment register inside there, most I can do is maybe give it a tap and tighten it down and see if I can remove any little play in there, and that just might be enough. So according to this, I am I'm moving away, so I'm pointed that way just a hair. So I want to tap it this way, counterclockwise. Of course, I should have tightened that up a little bit more, and I might have been fine. I didn't really notice if that slot was tapered and self-aligning or not, but I gotta assume there's a teensy bit of slop in there. All right, we'll try one smooth movement. Watch real fast. Actually, that looked better. It's really hard to keep pressure on this while sliding it. But if it moved a half a thou in the bit, I could watch it. That's better. I'm good. I'm not messing with it. Well, while it's being a slight pain in the ass, it's a necessary procedure. And I feel better now that I'm going to have better drilling, better center points, and better turning. So I hope you got something out of that, and sorry if it's all confusing. I didn't sit around and write a script because I find out if I do that, I procrastinate all day on how to present it rather than actually doing anything. So, okay kids, see you next time. Okay, we're back. Remember, if you adjust that and your nose swings over here, way out here, that's a big movement compared to back here. So I do have to realign side to side again. So if you do that, go back and double check and make sure you're still good. So just wanted to let you know that. So now I got to loosen this up again and move everything back a little bit over to that side. Okay. Now I'm done.